Okay, everybody, this is Todd Frazee again, and this is the S60-111 CAM tutorial for the primary piston cap. Alright, so this is a disc shape. It's going to be similar to the last one. You probably use less tools because the tolerance on the hole isn't all that great. So let's go to Solid Works. Here's our model, and we're going to, again, go to the CAM tab on the main menus. Then we're going to shift over on the feature trees all the way to the right to the last one, which has an end mill pointing down. And we're going to create a job. Okay, and this job is going to be turning, mill turn. And it's the S60-111 turn, not turny, complete. And that'll put it in the job notes so you know there's just one program. Okay, your model should be auto-selected. Instead of a rectangular box, we're going to go with cylindrical. Okay, and we notice our cylinders point the wrong way. Okay, so we're going to go to, before we set anything else, we're going to go down here to go to stock orientation. And we're going to use Z and X axis. And then instead of having the front plane selected, we're going to select the front of our part. That should orientate our hidden lines of the chuck and our material in the correct orientation. I wish they put this in order before you started setting the extra stock, but we're scrolling back up to do that. We need to determine what stock size we're going to use. So if we go to evaluate, measure, and we pick on the outside rim, it's 422 thousandths. So we're going to cut this out a 1/2 inch material. So if I were to go to my calculator, 0.5 minus 0.422 is 78 thousandths. We're going to divide that by 2 because we're putting it as a radial number. And it's 39 thousandths. So we go back to SolidWorks, and radial stock offset is 0.39. I'm sorry, 0.039. Okay, and so that's how much material the yellow represents. We're starting with a thicker piece. Okay, the front side offset, we're going to put a little bit on there. So we're going to put, let's put a 0.010, 10 thousandths extra material on the face. Okay, and then on the back side, we're going to put 2 inches. Okay, so it's a 2-inch long bar minimum. You could have a longer one, but that's minimum. And the stock that's within the chuck, we're going to do the same as we did last time. 1.6 inches are inside the chuck. The rest is exposed. So you got to be careful with collision detection. You're not running into the chuck. Okay, we're not clamping from inside, so we're going to leave that alone. Okay, so we're going to change our origin from stock front to the actual model front, which compensates for the extra material we have. So when we've machined with the facing cutter on the face of this, we've qualified the length. Roll down, we're going to go to a program name, and we're going to call this the 1111. Okay, so it's the first program for the 111 part. Program comment is S60-111 op 1 for the lathe. So we've identified what type of program this is for the operator. Alright, so we should be able to accept all that information now. And if we select on the job, we should have this material. Okay. Now in the job, let's change the job name. Let's rename it. And it's also going to be the S60-111 op 1 for the lathe. Okay, so when we have multiple programs, we'll have them segregated by operation and machine type. All right, so we're gonna do something similar to what we did last time. So we started off with a 2D turning, and we did a turning face, and we're gonna select from our library tool number 1 is our grooving tool. It's a cutoff tool and facing tool. Select that, and we can see a representation of it. Okay, we're going to leave all this at default. Geometry, we can pretty much leave that at default. Our planes, we're going to leave the first 2 at default. And our outer radius is from the stock outside diameter, and we're going to go to the model inside diameter, okay, which is the smallest diameter on it. And then we're going to go a little bit farther, so I'm going to go 0.01, 10 thousandths. I can't remember if that was what we did on the last one, but we're going to go to the next stage. We're going to leave everything at default except we're going to go to where for compensation control. And on this last page, all we're going to do is change the angles of our approach. For this type of cutter, you don't want to come in at a 45. Okay, so we're going to come in at 0. Now we're going to come in at 90. And then our lead out is not the same. We're going to come out at 0. And we're going to leave the default 0.08 for our lead in, lead out. We'll hit accept. Okay, so this is quite a bit bigger in diameter part than some of them. Okay, so we've done our turning face. Now we need to turn the exterior to take it down to size. You go to turning. We're going to use a turning profile tool. We're going to select tool number 3 from our library. Okay, it's a diamond shaped insert. We're going to leave all this stuff at default. We're going to go to our geometry, and we're going to use a confinement, and we're going to go past by the width that would cover a cutting tool for the parting tool, which is 150 thousandths. We're going to extend our cut by 0.18 to make sure that we're going past. Now we're going to go on the next tab, and we're going to go from retracts fine. Our stock OD will be the retract clearance. Our outer radius is going to be from the stock, and then we're going to go to the model outside diameter. We're not going all the way through the part, so we're just turning down the outside. And then we're going to switch over to the next tab, which we're going to leave everything at default, except for we're going to take away roughing passes. I don't think we need them on this. And we're going to change our compensation to where. And then we're going to move on to the next tab. And we're going to set this allow radial and axial grooving. We're going to set that to not allow grooving for what we're doing. And then we're going to go to the next tab. We're going to leave that at 80 thousandths. We're going to change this to 0.1 as a lead in. And we're going to go at 0 degrees. We're going to have a lead out, but it's not going to be the same. We're going to lead out at 90 degrees. And we're going to go, and we're going to deselect this pull away before retract. And what that will do is give us a feed out to feed off the part on this little flat edge here. Okay, so let's go on to the next operation, which is the spot drill this hole. So we're going to go to drilling, we're going to use the standard drill command. We're going to go to our library, and we're going to go to our lathe tool library, and we're going to select our 1/2 inch spot drill. We're going to select that drill bit. Okay, we're going to leave the first page at default. We're going to go to the second page. We're going to select the hole we're drilling. Start in the center there. Okay, we're going to go skip to the next edge, and now again it's like a mill. It's treating the face of this part as if it's the top in reference to the cutter. Okay, so we're going to leave 0.4, we're going to leave 0.2, but it's going to be from the model top, not the stock top. And our drilled hole is going to go from the top of the hole, but our bottom is also going to be the top of the hole, because we're going to put in a punched in value here. It's 94 to 99 thousandths. So if we take 1/2 of 99 thousandths, divided by 2, and if we add 10 thousandths, we get 59 thousandths 5/10. So if we put that in here, negative 0.059 thousandths 5/10, we will get a slight 5 thousandths chamfer all the way around that hole. It'll help the lead in for anything that goes in there. Okay, we're going to go to the next tab, and we're going to do just a standard drilling cycle. So it goes in, drills to a depth, and then pulls back. We're going to accept that, and then here we've got our little countersink, okay, from our spot drill. Okay, so we're going to change the name of this to spot drill. Okay, and we're going to go on to the next operation. So it's another drilling operation. We're going to drill. We're going to select from our library the same tool we selected for that. So we have a 99 thousandths top end hole with 94. So I would say that we're going to use this 98 thousandths drill bit, which we'll have in position number 9. And we'll leave all those settings at default. We're going to drill this hole here. Okay, so we selected it. We're going to our planes. Our retract height is going to be model top. And then we're going from the whole top all the way to the bottom. But we want the tip of the drill to go all the way through. And we want a little bit of extra margin. So we're actually going to go 0.180, which is the same amount that we machined off on the outside. So our parting tool will come through and cut right through that diameter to release the part. So we don't have to all the way to the center line. And then our next step, we're going to do what's called a deep drilling cycle, because this is a soft material. And we're going to do a peck depth of 40 thousandths. We're going to call that good. Okay, so now we've drilled our hole through this part. Now the next and final step on this one is to part the back of the part off. Okay, so we're going to go to turning, and we're going to do a turning part. We're going to go back and select tool number 1, which is our grooving cutting tool. Okay, and flood coolant. Go to geometry. We've already got it selected. We've got all our numbers here. We're going to go from the we're going to change the outer radius to our model ID. Okay, and then we're going to go not from model ID, but we're going to select a feature, which is going to be the hole. So we don't need to go all the way through. We just need to go down to a little bit past that diameter. And we're going to go a little bit past the diameter I just selected off that face. by 0.01, 10 thousandths. And so that'll give us our feed in with the cutoff tool into the hole. Okay, we're going to move on to the next tab. We're going to leave everything at default. Go into the last tab. We're going to do full retraction and accept. Alright, so now we're done with the programming for the second part in our series for the lathe, for the S60-111. Now let's simulate and see what we did. Stock simulation. Okay, let's play. So we come in with a grooving tool, face it, go around the outside. Now we're doing our pectoraling. Now we do our parting, and then we're done. We're going to close that, close the simulation. Alright, so you should upload one file that's a setup sheet and one file that's an NC program for this project. Alright, good job. We'll catch you on the next one.